Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Chui Mingjun. Today, we will study Chapter 3, PLC Program Controlled Punching on the Training Bench, Servo Motor Control Subprogram, Y-axis Turret Stepper Motor Control Subprogram. This lesson focuses on mastering the complete operational logic of the Y-axis Servo Motor Control Subprogram, including manual operation, automatic punching, and homing operation. In this lesson, I hope you will gain a deeper understanding of the critical role PLCs play in industrial automation, laying a solid foundation for future learning and work in the automation field. First, let's look at Program Segment 1. In the Y-axis subprogram control, the subprogram is automatically called after power on via SN0.0, normally open. This step is crucial as it handles the initialization of the motion axis configuration. Every time the CPU enters run mode, it automatically loads the configuration and motion curve table. Each axis is initialized only once, but this process needs to be executed in each scan. The mod parameter is another key point, which includes M9.7, Y-axis home position flag, and M0.1, stop flag. Only when mod EN is enabled can other motion control instructions be executed. Otherwise, if mod EN is disabled, the current instruction will be aborted and the motor will decelerate to a stop. Notably, when M9.7 equals 1 or M0.1 equals 1, the Y-axis subprogram will stop running. This design ensures the equipment can operate safely and steadily under specific conditions. Next, we move to program segments 2 to 3, focusing on manual mode of the Y-axis. When I0.6 equals 1, it indicates that manual mode is activated. At this point, the negative direction signal is assigned to M9.3. If the Y-axis negative direction button is pressed, M9.3 will be set to 1. Once the run parameter is triggered, the servo motor will operate at a speed of 50, with the direction controlled by the status of M9.3, 0 for forward direction, and 1 for reverse direction. During operation, although the speed can be adjusted, the direction must remain fixed once determined. When run is disabled, i.e., I0.6 equals 0, indicating that automatic mode is activated, the motor will decelerate to a stop. In addition, jog operations can be performed using jog P, forward, or jog N, reverse. To ensure system safety and traceability, any error status will be stored in VB80. At the same time, the current position, VD82, real-time speed, VD86, and direction, M9.2, will be updated simultaneously. Next, we move to Program Segment 4, which involves the Y-axis automatic movement mode. When the EN bit is enabled, the subroutine is activated and must remain active until the done bit, M9.4 equals 1, confirms completion. The start parameter is triggered by edge detection to issue a single go-to instruction. In automatic mode, the device performs different operations based on specific conditions, such as punching holes 1, 2, 3, 5, 8, and 9, controlled respectively by M5.1, M5.3, M5.5, M6.3, M7.3, and M7.5, homing after punching, M8.0, or reset, M2.0 equals 1. The device will move to the position set in VD106 at a speed of 50, in either absolute mode, mode equals 0, or relative mode, mode equals 1. Once the operation is complete, the error status is stored in VB90, while the current position, VD92, and real-time speed, VD96, are updated simultaneously. This design enables automatic device operation, enhancing production efficiency and operational accuracy. Finally, let's look at program segment 5. At this stage, the subroutine changes the current position value 0.0 of the motion axis to a new value. When the electromagnetic clutch is triggered, value equals 1, meaning the punching mechanism is connected to the AC motor. The new value replaces the previous value, such as 20.0. Once the motion axis completes this subroutine, the done parameter is activated. The error parameter reflects the result of the subroutine, while the CPOS parameter contains the current position of the motion axis. This step ensures that the system accurately records and updates the position information after each operation, providing a reliable reference for subsequent actions. Today, we've thoroughly learned each part of the Y-axis servo motor control subprogram, including initialization, manual mode, automatic movement mode, and position modification. This subprogram is a key component of PLC-controlled punching on the training bench, enabling precise control and automatic operation of the equipment. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.